This video touches on the topic of suicide. You might be coming to this video as a researcher or suicidologist who engages in this subject matter in your work, as a survivor of suicide or suicide loss who has been personally impacted by this subject, or as a policymaker looking to translate research into policy. However you're showing up today, the topic of suicide can evoke a deep pain and emotion. Before we begin, I'd like to start with a few grounding reminders, borrowed from Dr. Jeffrey Anslus. You may want to consider checking in with yourself to decide how and when to best watch this video. Maybe you want to watch it with other people. Maybe you want to watch it in the morning and not late at night. We invite you to bring a good heart, a good mind, and a lot of compassion for all as you watch, including yourself. Feel free to take a moment now to pause, reconnect with yourself, and reflect on how you plan on engaging with the content today. There are resources available to you should you want to talk to someone. Depending on where you are in the world, those resources may look different. In the description of this video, we've provided some places to start, with options to get help for yourself and help with supporting someone else.
13 method seminar. Some combination of synchronous and asynchronous adds up to 13. Here's the link to the Basecamp thread where you can watch the previous recordings. Our last one with Trevor was fantastic. There was a whole bunch of resources shared there. So definitely go back, check out that recording. And Annie did a great job of capturing all of the papers that were mentioned during that seminar as well. So those are in that folder that's linked on that Basecamp thread. So drop that in the chat for folks in the center. And then we have Sarah with us today. Super excited for Sarah's presentation. I'll do quick intros and then just pass it off to Sarah. So Sarah McInerney is a 6-year clinical psychology student and PhD candidate at the University of Colorado, Colorado Springs, with clinical and research interests in the area of suicide prevention and healthy post-traumatic recovery. Prior to starting graduate school, Sarah served on active duty in the U.S. Army, during which time she was deployed twice in support of Operation Enduring Freedom and commanded an aerial delivery detachment comprised of parachute riggers in Germany. She is currently completing her predoctoral internship at a community mental health clinic based in the Denver metro area and still serves in the U.S. Army Reserve in a drilling status and holds the rank of lieutenant colonel. Sarah, take it away. We're excited for your presentation today.
All right, cool. Yeah, thank you. If I'm looking to the side, it's because I have the slides in front of me and all of the faces are to my right on a separate screen. So that's why it may look like I'm going every which way. But thank you for the introduction and getting this all set up. And I'm excited to talk to you guys about catastrophe cusp modeling. So, I gotta click it. Okay, here we go. Again, this is me. He was already introduced, but again, a little bit about me. I'm a PhD student. I've been working here in a program in clinical psychology with a specialization in trauma. So different than some generalist programs, I know a whole lot about trauma in terms of research and clinical care and less about other things. And so with that, to understand how change happens over time, I've taken an interest in learning some of these different longitudinal methods to be able to understand how change happens for people. So today, I'm hoping to describe the theoretical and conceptual foundations of catastrophe cusp modeling and show you guys how to interpret the results of the analyses in hopes that you guys will be able to apply it to detect nonlinear changes in suicide risk. And so in learning this, I actually was working very closely with someone who is a physicist by trade, and he took the time to really show me and mentor me in terms of how to understand and apply nonlinear dynamical systems methods to understand social science in essence. So that's what I'm hoping to describe to you today. I know enough to be dangerous. I would not call myself an expert by any stretch of the imagination. There's a lot to be explored and learned, and I know one teeny piece of it that I'm hoping to share with you. Again, this is an overview. What I'm hoping to do is go over the foundations, describe data requirements and the conceptual and practical limitations of this method, and review 2 studies I conducted for my dissertation that applied this method to detect changes in suicide risk. I also, when I ran through this, I have plenty of time for questions, so please feel free to interrupt me. It's not going to throw me off. I prefer dialogue. I'm used to talking to undergraduates who tend to go back and forth. It just helps kind of move things along. So just, raise your hand or speak up. It's not going to throw me off. But moving on. So catastrophe cusp modeling is one method in this larger realm of nonlinear dynamical systems methods informed by nonlinear dynamical systems theory. And so what this theory is broadly is to understand, predict, or characterize changes in system in space and time. And so what does all of that mean? Well, systems are complex entities. Anything can be a system. So we can talk about people as systems. We can talk about couples as a system. We can talk about therapeutic dyads as systems. We can talk about atmospheric conditions as systems, right? So the system can be anything that is a complex entity in any field of study. And it's comprised of several working parts that dynamically, bidirectionally, fluidly, variably interact with one another to produce behavior in that system that can't be explained by any one of the individual parts. So again, this whole concept of dynamical systems theory is to be able to model and predict and describe very complex systems. And people are one of many, many complex things that we can talk about. So nonlinear dynamical systems theory is informed by 2 other theories. And so we have chaos theory and catastrophe theory. Chaos theory is looking at the way that small changes in predictor variables can result in sometimes big changes later, right? So we think about the butterfly effect as kind of a way to think about it. So again, the small changes in atmospheric pressure from butterflies flapping their wings can result in tornadoes, hurricanes, etc. So that's the kind of idea with chaos theory. And with that, chaos isn't good or bad. It's just that we have a limited ability to be able to predict. So it's the state of disorder. And a way to think about that is if one person were to kind of get in the space of another person about 2 inches from their face, right? It's hard to predict what's going to happen, right? Maybe that person is going to hug that other person. Maybe someone is going to shove the other. Someone's going to step away, right? We don't know what's going to happen, but we know something is going to happen, right? And so that idea that we can't quite predict it, that's what we're talking about with chaos. And statistically, it's not different. Mathematically, it's exactly the same as randomness. So when we do the mathematical equations, it's exactly the same. So one can think about it in that way. It's not good or bad. We just can't predict it. And so that's chaos theory. Catastrophe theory is focused on movement of systems across space and time. And so what we mean by that are sometimes there are sudden shifts that can occur, and other times there are gradual changes. And it's trying to understand and characterize, predict that. And the folks in the world of mathematics have identified that there are 7 catastrophes, which I thought was interesting. And they get with varying numbers of control parameters and behavior axes. And it can get very complex depending on what kind of catastrophe we want to conceptualize in multiple dimensions, and it can get very ethereal very quickly. So the catastrophe cusp is just one of 7 potential catastrophes that can happen and that have been modeled mathematically. And so we're going to be talking about 2 control parameters on 1 behavioral axis. Any questions at this point, by the way? I realize some of this stuff may be a little bit heady and get there pretty quick. And so I don't want to leave anybody behind if this is getting a little bit much. Everybody good? Okay, good. Awesome. Thank you. So key terms and concepts I think that are important when working in this world, and it's words that you may see or stumble across either when looking at discussion sections of papers or when looking at method sections. It's just concepts that are important to know. Emergence, this is what we talk about when a system exhibits a pattern of behavior that is new or different from what existed before. So that's what emergence means. Emergence happens through self-organization. And so this idea of self-organization is that systems tend to orient themselves around a couple of parameters that we can talk about in a bit, but that they eventually get to where there's some sense of stability. And so in terms of people, we can think of this idea of emergence and self-organization as folks kind of going about their everyday lives and functioning or existing in some kind of way that is normal for them. And then if something happens externally, right, something else can emerge. And this happens through iterative feedback loops from all of these variables dynamically, fluidly interacting with one another. And so when we talk about states, this is a stable sense of equilibrium, right? So that's things tend to like to be at some sense of quote normal, right? So stability, equilibrium. It doesn't necessarily mean it isn't dynamic. There's still stuff happening internally, right? Again, we're talking complex systems, but in the absence of external variables interacting with it, it's going to behave in some kind of way that is stable. It is dynamic, it is predictable. And so with that, states can change, and there are two kinds of changes that are important to have some conceptual reference or framework with. And so these transitions, we have parametric change and we have order transitions. And so with a parametric transition, what we're going to have, or within a system, there could be parameters or variables, some of which change in a way to elicit some systemic movement in space and time that is typically gradual. So the system is going to largely stay intact. There might be some movement, some disruption, but largely the system itself isn't going to decompensate. It's not going to sort of fall apart, if you will. And so the system is largely intact, some change. Order transitions are different. So this is going to be an entire decomposition of that system, and it's going to reorganize itself in a separate state around different parameters. Again, it gets complicated. So if I'm losing anybody, please ask me for clarification. I'll do my best to explain. So that's what we're talking about with these kinds of systemic changes. And when interpreting our results, it's a little bit different than we might think of traditionally. So we're going to be focusing on variables being, or systems being stable or not stable, kind of somewhere in that spectrum. And we're going to be focusing on kinds of movement or kinds of change. So we're either looking at shifts where it's discontinuous, sudden change in our outcome variables, or continuous gradual change. And what's notable with discontinuous change or shifts is that in order to do so, the system has to pass through a disequilibrium state to get there. So there's going to be some sort of decomposition. That makes sense? Am I losing anybody yet? Okay, good. All right. So again, a catastrophe cusp model is one of a variety of nonlinear methods we can use to detect nonlinear changes. It's specified by it's specified by three factors. So we have an outcome variable. So in the case of what we're going to talk about here, SI was my outcome variable, and two predictor variables. So we're going to have an asymmetry factor and a bifurcation factor. And so I'm hoping you guys can see my mouse. And so three-dimensionally, it's, again, we're going to have to think a little bit differently as opposed to what we might think of in terms of just normal line graphs and change over time. It operates on a three-dimensional plane. And so these asymmetry factors, this is what is going to be resulting in state change. It can go up and down, but this idea that it's gradual, that is what we're looking at with asymmetry factors. And then with the bifurcation factors, it's going to be pushing it this way, okay, in a different direction. across to where this fold region is, and that's the sudden shift, right? So that's when we're talking state changes in states that are very sudden and rapid. And so, and this whole plane basically is existing, you know, as the outcome variable. Does that make sense? Am I losing anybody yet? Everybody's good. Okay. So that is what we're talking about here. And so in order to be able to do that, there's a couple of things, a couple of factors that would suggest within a data set that this is an appropriate method to consider using. First being bimodality of outcome. And so when you're looking at your outcome variable, if there are two tendencies in one direction or the other, and this is, I'm going to be vulnerable with you all. So in terms of the sort of my mishaps as I figured this method out, bimodality does not mean binary. And so what I did, even when I was doing this, is I coded the outcome to be, you know, SI present, not present. And then I ended up just having, I basically did a nonlinear logistic regression, which, while interesting, was not what I was trying to do. So again, you're going to want a continuous variable here in terms of what it is you're looking at, but you have two general outcomes. It's either this or that, right? And that would be suggestive of two different states. That might indicate that this, maybe we can give this method a go. If there are sudden or abrupt changes, even with small changes in the predictor variables. So again, you know, there could be continuous change amongst your predictor variables, but there are just rapid, like just, again, very sudden changes. That would be suggestive that maybe we should give this a go. If there's inaccessibility. And so what I mean by that is that with that bimodal outcome, that it's unlikely to fall in between in that middle space. Again, because that would suggest that there is not necessarily two states happening. Hysteresis, so there has to be a time delay, and really that kind of implies that, you know, time, like, but initial states matter. There's some sort of, between the predictor variable and the outcome variable, there's some kind of time delay to allow for a state shift. And mathematically, you can't get the different outcomes from the same predictors. So that's more in the weeds of the math, but that's also something that's important to consider. And it has to be nonlinear. So again, looking at your data, if it looks like there's sort of a nonlinear pattern happening, that's important. And so limitations, so I will specify, I used a very particular way to run this model. I used Cobb's method you know, and all the R commands that described by Grassman and colleagues. So there are other ways to run this model. Guastella and colleagues from my alma mater at Marquette University. He also has a way to be able to do this. It is different from what I'm describing. I can't speak to it, but it is a different way. So the limitations that I'm speaking of here are specific to Cobb's method. And so when I ran it, R did not seem to like non-complete cases. And so it would give me these not a number responses and error messages. So I had to put in a code, which I have at the end of the slide presentation, basically to get R to tolerate missing data. And so that's more of the practical limitation, is that you're going to need complete cases. And if you don't have complete cases, I ended up having R screen them out. When you look at the results, it will not give you the directionality of the movement. So we'll talk about, when we're looking at the output, it's not telling you up or down. It's not telling you more or less. It's telling you the kinds of movements. Are we getting shifts? Are we getting gradual movements? That's what it's going to tell you. It is not going to tell you it's shifting up or shifting down. You'll have to do post hoc analyses to get that, which I can also speak to, and I ran, but it's a separate command. It's not going to give you that in the initial output. And it's going to show you how systems move across time with limited insight into how much. So I can tell you that it went up or down. I can't tell you how much it went up or down. Does that make sense? Nice following. Okay. We'll get to actual what I did in my dissertation, but it can get really heady really quick. I want to temper expectations because it can get very complicated. So using fluid vulnerability theory. This is a way to conceptualize suicide risk, and this is what I use to inform my dissertation. So the way that Craig Bryan and colleagues have described this is that it's drawing from dynamical systems theory, and these risk and protective factors dynamically interact in order to shape risk, and that risk doesn't follow a uniform trajectory. So again, we're looking at risk. Some it's gradual, some it's rapid, right? So you have that shift, that jump. And so to consider suicide remission in SI, I was like, well, let's go ahead and take a look at maybe recovery operates on the same plane. And so I'm making some assumptions here. I'm not going into the weeds of Kate's data. I'm making some assumptions that folks are somewhat well versed with that. But historically, it's been a pretty consistent pattern that those who receive CAMs tend to get better faster relative to treatment as usual. And so I was curious as to why. Dave Job says hope. I'm willing to go with Dave. He seems to know what he's doing. And there are a lot of theoretical reasons as well, right? So Snyder and colleagues have this hope theory. I won't go into the weeds with it. I would encourage you guys, once it's finally finished and done, you guys can look at my dissertation. I wrote all about it. It's fantastic. About hope theory and why I think that it's a mechanism of change. And largely, in a nutshell, the suicide status form with the safety planning, I think taps agency thoughts and pathway thoughts to be able to help folks cultivate hope to get them out of the crisis. And so that was my thought process with that. I was like, okay, well, hope is the mechanism, could be the mechanism of change here. This could be a suitable way to evaluate changes in suicide risk. So again, I thought it would be interesting. And what's cool about the catastrophe cusp model is that it is robust enough to detect nonlinear and linear changes. So again, even if nonlinear is not the thing, you can still identify the factors associated with gradual change. So again, it's a pretty robust method that can tell you a lot of information. And so in my dissertation, my study questions were, is the rapid recovery associated with CAMs explained by changes in hope that result in nonlinear shifts in SI? And this is the post hoc analysis that I did. Are the differences in idiographic trajectories based upon treatment conditions? So do people in the CAMS condition exhibit one trajectory at greater rates than the other, right? So I did a Fisher's exact test for that. And using two separate data sets. So again, Kate was generous enough to share her data with me to be able to do this. I looked at data from Operation Worth Living, the active duty sample that she conducted with Jobs and colleagues in 2017. She published on that. And AFS, Aftercare Focus Study, with recently discharged inpatient psychiatric patients. The reason why I ran it as two separate studies is because the samples were so qualitatively different. I did not think it would make sense to evaluate them in the same model, because I think there are a lot of demographic and quality differences amongst the groups that might have different, just have different patterns. So my hypothesis with this study was that hope would trigger nonlinear shifts in SI, and that two trajectory types with this last line of code that I ran, that there would be a gradual decrease and a sudden decrease trajectory. So that was what I thought was going to happen. Additionally, I thought that those in the CAMS condition would exhibit a sudden decrease trajectory. It's a general procedure. So what I did for both studies is I specified models, and then I conduct, with all of the R code, informed by theory, all that good stuff. And then I conducted a series of post hoc analyses to categorize the idiographic trajectories of folks over time. And then I evaluated group differences. Any questions? I mean, it's largely pretty straightforward. So looking at the models, so based on the variables I had within Kate's data, there were some differences, but largely the model is the same. So I wanted to see as asymmetry factor, which is the gradual change, mental distress, which as that goes down, I would expect SI to go down gradually. And I have a lot of theoretical reasons for that. And with hope, as hope increases, I would expect a shift in SI, so a sudden change plus treatment. And so that's exactly what the code is going to look like. I have at the end all of the nuts and bolts of what the R coding looks like, but this is what it is. So based on the variables I had from Kate's data, all the variables met all of the validity and reliability metrics we tend to like to see in data. Her data was very good. I didn't have to wrangle it in any way to correct it or anything. So these are the models that I ran. I have slightly different variables for SI because that was what Kate collected in these data sets. I added statistical controls as well, partially because I thought it was interesting and I had it, and I thought that would be kind of cool to run to see if there are other things that shape this. And given that it's a dissertation, there was also some committee-made decisions, so which is why I added the substance use here in study 2. They just wanted to see substance use, and I was like, all right, cool, I'll give it a go. Any questions in terms of what I did or how I did it thus far? Everybody tracking? So how we're going to evaluate these models, right? So that's what I ran. This is how I know if the model is going to be good. So first thing we're going to look at is parameter estimates. I want to see that they're significantly different than 0 and that they're significant at the 0.05 level. So that's sort of the first check mark. The next thing I want to look at when I get the output is there's going to be a chi-square test of likelihood. It's going to be evaluating the cusp model relative to the linear model. So these are, again, just stuff that R will spit out when you tell it to. And so I want to see that that is significant, that the cusp is significantly better if the results are significant. And your information criterions, your AIC corrected BIC, I want to see that these numbers are lower. Lower is better. So that all of that kind of comes together to make a decision, but it's a little bit fuzzier than one might get when working with traditional linear models because those conventions are pretty hard and fixed in terms of what we want to see in various indices. Also, something that's important to know is that we're using what they call the delay convention. So R will also give you what they call a pseudo R square. Gives you some insight into the amount of variance the model accounts for, but it is not a one-for-one synonymous with what you would typically see in an SPSS output with an R square. And so it's less meaningful. It gives you some insight, but just because it's not significant or it's not, one is higher than the other, it's not enough to be able to reject a model to say, oh, well, the linear model had a higher R square. Like it's mathematically different. And using this convention again, when we're calculating it mathematically, what they're doing is calculating the distance each data point has to the closest modal point as opposed to the most likely. And according to the folks that have done the mathematical work in this, it's recommended for social science, and I'm willing to follow the guidance of experts at Grassman and colleagues. And so interpretation of these results. Okay, so we've looked at the model, we like the model. Now to be able to determine what these things mean. So we have our asymmetry factor. And so when we look at that, when we're looking at the values, this value is associated with gradual transitions. So a positive value here means that a greater amount of that variable in the absence of influence from the bifurcation factor results in a greater amount of that outcome variable, right? So higher means more outcome variable. Make sense? Okay, I'm assuming everyone's makes sense. Okay, perfect, good, thank you. Bifurcation factor, this is different. This is where it's different. Again, three-dimensional plane. So a positive value here does not indicate that it's shifting up or down. It's not what it means. It means that a greater amount of that variable is going to push you towards that fold, that place where and if there's a threshold that's met, and we can mathematically figure that as well. Oh, thank you. So if we're pushing, like I said, if we have a greater amount of that bifurcation variable, it's pushing us towards that fold. And if it has enough of that threshold, it'll jump one way or the other. So it's more of an indicator of likelihood of chaos or a shift change or a shift. Make sense? Again, not up or down, because folks can get confused by this. So this is where, for anybody, I'm going to date myself. This predates me, but this is where I think in terms of my dissertation, I jumped the shark, for anybody who knows what I'm talking about, Fonzie and Happy Days. So the idiographic trajectories, while interesting and informative, I doubt very much I will actually publish on this bit because it gets very confusing. And so what I did was I ran a line of code that categorized each of the individual participants' trajectories relative to the nomothetic cusp model. I'll say that again. So it's all of the trajectories and how their movement related to what we would expect in that cusp model. That is not necessarily idiographically people went up or down. This is their movement in relation to that model. So a way, as I was trying to figure out what my data was telling me, is determining if we look at the nomothetic model as a swarm of bees, right? The bees are going to go one way or we're going to go the other way. That's information. It's meaningful and it's helpful to think about, but understanding exactly how each of those bees are moving in that swarm becomes less meaningful. And I think that's kind of when we get to my results, you'll see what I mean, but I'm prefacing this so that way that doesn't get misunderstood. And so what this is telling us is that the individual on that nomothetic model exhibited either a gradual movement or a sudden shift, like the pathway. When R strung them together, it just went across pathway, either went up or down. Okay, and you'll see what I mean, because it's going to look like it's funny results and everyone got worse, no one got worse, everyone got better. And so here's what the output looks like. I cleaned it up. R will give you something that looks very similar to this. So for OWL, this is what I ran. So I ran that mental distress, that's the OQ45. This is the SF36, SF36. Mathematically, they're intercepts. I don't care about those. There's the bifurcation factor and the outcome variable. I highlighted the ones that were significant, right? So, and the intercepts are significant. I also don't care about them. So here we go. So this is where we're looking at this, right? Our AIC is lower. Our AIC corrected is lower and lower than the linear model, and it's significant, right? So that is the first model. I ran it a second time without all of the excess noise to see if it could fit better, and it really didn't change remarkably much. Some things got more significant. Hope got more significant here. So what this is suggestive, right? Again, this is confusing, but it's clear in my manuscript. So looking here at this mental health, that's the SF36. That indicates higher is better there, right? So as our mental health perceptions go up, our SI goes down. That makes sense, right? And that fits in the model hope. As that goes up, we're accelerating towards a shifting point. In SI, again, it just fits well in the model. Does that make sense? That's what this is telling us. Again, and these are all the evaluations. So this is pretty novel stuff, right? So check this out, pretty cool. This is what it looks like in terms of a shape, right? So when we put it on a plot, this is everybody's in the hot tub. I ran it so that everybody is in the model. This is not accounting for time. This is to get that nomothetic cusp surface. And so I'm pointing the mouse here. See that little region right there? That is the inaccessible region. That's where the jump is happening. And so I didn't, but I could go through and identify what the threshold is, how much hope is needed for that. That's a command you can ask R or a value that R can give you. I just didn't pull it out. So it's pretty cool. So again, it's suggesting that suicide risk and recovery kind of operate on the same plane, which is cool. So post hoc analysis, this is where I jumped the shark again. So I ran that line of code. And these are all the trajectories that emerged, right? So I only predicted 2, and this is what I got. And I was like, what in the heck is going on here? So looking at all of that, and what's really cool or fascinating, I'm not sure if this is cool, but it's interesting, is that even when you separate it by cams and control, it's almost exactly 1-for-1 split right down the middle. So that's interesting. And I'm not sure what's going on there. That's the stuff of future research, but that is what we were there. Again, per request of my committee, I did a ton of group differences just to see if I can sort out what's going on or make some rhyme and reason out of all these trajectory types. And it can't be explained by baseline depression, baseline alcohol use, baseline PTSD. None of that stuff matters. There was a significant difference between baseline hopelessness, but because we had deviated so far from my a priori hypotheses, I didn't tease it apart further because I don't know that it would have made any sense. And so again, this is what everybody's individual trajectory falls relative to the mathematically derived model. This isn't suggesting folks got worse. They didn't, because I went through and I pulled everything on the Excel spreadsheet and I was like, I don't understand what's going on here. Everyone's getting better, but it's a gradual increase. I don't understand. And what this is I think it's all variability within, again, all of the mathematical stuff. So if we're looking at a linear regression and there's all the fuzz associated with just where we get that line, I think that's what we have just modeled right there, is just all the fuzz that would be associated with a mathematically derived model. This is what it looks like. I didn't put this in my defense, but I wanted to show this is what we tried to model, right? So it is a mess. Idiographic analyses is it's a lot to think about and a lot to conceptualize, and stuff of future research and code writing, for those who'd be interested, really are deriving latent classes out of that. It would require, that's kind of the limit of where we're at in terms of social science. This stuff can be done, and somebody's going to have to write the code in R to make it happen. So that stuff doesn't exist yet, but it's, anyway, stuff that could be done in the future. So again, this is kind of where we're at in terms of study one and hope triggering nonlinear shifts, right? So that was supported. We got way more than 2 trajectories, so that was partially supported. And CAMS was not any more likely to exhibit a sudden trajectory relative to control. So that was OWL. Now this is AFS, right? So looking at similar variables, right? That mental distress is the OQ45. There's hope, that's with the OHS scale instead of the CD risk that I used in the last study. The treatment condition, so that's CAMS, and then your SI, right, with the BSS, as I think is what it was. These all were significant, fit in the model. It's lower here slightly here on your indices. Again, this R squared, I'm less interested in. It's somewhat meaningful. I don't really hang on to it. I wouldn't suggest it to reject a model. It's enough to give you some insight, but again, not enough to reject in the event that the linear is higher, for example. Our chi-square here is significant, right? Suggesting the cusp model is better. I dropped all the variables that weren't significant to see if I could get it to fit better. And it did. I mean, it got a little bit more significant in areas, but really nothing changed remarkably. And so that's where we're at. Same thing here, mental distress. So this higher is worse, right? So as your distress goes up, your SI goes up. That makes sense. As your hope plus CAMS here, right? So that's different than the other group. Hope plus CAMS will accelerate you to that shifting point, to that bifurcation region where you'll go up or down. We don't know which. That's not giving you directionality. Something's going to happen. We don't know what. And yeah, so that's that. This is what it looks like. Similar shape. It is a little bit more drastic here, right? So that bifurcation region, again, is a little bit wider with the AFS plus treatment. And this is the idiographic trajectories. So when I ran this code, we had fewer trajectories emerge, and most of them were gradual increase, which I was like, what's going on here? That's relative to the model. So again, everyone still got better. I went through in the weeds to evaluate it. I think we'll talk about that in the discussion. I'll talk about what I think that means. Again, basically the same pattern here in terms of CAMS and control, which is also fascinating. And is the stuff that we could, future research can sort out. No significant difference in any of these ways based on baseline expectancy beliefs, treatment conditions, substance use, or physical health perceptions. This is what that looks like. Again, it's a big old mess. And so to get latent classes out of that would be the stuff of future research. I'm going to pause here for questions. Are there any thoughts thus far before I go into what I think all this means? Okay, thanks. You guys are a quiet group. All right, so again, hope triggers nonlinear shifts in SI that's supported. That's cool. We have two trajectories that would emerge partially supported. It was more than that. And then it was not supported that CAMs would be more likely to have a sudden decrease trajectory. So general discussion, again, kind of collating that similar patterns amongst both studies. And so what do I think this means in a nutshell, without doing a total deep dive into my discussion? Hope triggers nonlinear shifts in SI. This is an important novel finding, and it really provides empirical support to what Dave has been saying all along. So when I write that up, I'll be sure to, give Dave all the kudos and give him a high five. Treatment condition also triggered nonlinear shifts in study 2 in AFS. So that is interesting. And what I think is going on there is that it's suggestive of the differential influence of treatment between the samples. And so historically, at the same time as data collection was happening for OWL, the military was also rolling out its Universal Resilience Enhancing Program, which is largely based in CBT, among other things. There's literature in terms of what that's all about. That was happening at the same time data collection was happening with OWL. And folks in OWL are active duty service members. What does that mean? Well, they have access to healthcare, and many of them have had prior engagements with or interactions with the healthcare system. And it's possible, due to the resources available to clinicians and clinics and all of that good stuff, that these folks may have already had some experience with evidence-based treatment. I can't tell you what, but it's possible that they may have, based on how the healthcare system works there and the way that they try to incorporate evidence-based practice. Folks in AFS, on the other hand, may not have had access. Many of them did not have healthcare. Many of them may not have had prior encounters with clinicians who had access and resources to be able to deliver evidence-based treatment. And so it's possible that CAMS was their first encounter with any evidence-based treatment. So that's one theory that I have as to why there's a differential influence of treatment, I think is really characteristic of some of the demographic differences between the groups. And so going in that, anyway, so moving on, going into the trajectories that emerge, I think that it's suggestive of different change processes. And so the sudden shifts that occurred could be suggestive of order transitions, right? So folks had enough of a transition somewhere in their psychosocial system to have a state change, right? And that's what that could mean. And I think these gradual trajectories up, down is indicating parametric transitions and really systemic stability, which would fit with AFS and OWL, because again, largely as a group, everybody in OWL got better. Folks in AFS, they did not get as, there was not as remarkable of a change. And I think that's suggestive of systemic stability within the group. But again, I could be wrong. Those are my thoughts for what they're worth. And then really, so if you actually want to run a catastrophe cusp model, this is how you would do it. So you would need data, obviously. And R can read SPSS files, or it can read CSV files. So again, depending on the kind of data you have, you would have to, from R, download, or however you do it. You get it from the library, but you'd have to, install. You'd have to install the Cusp package, the Magrittr package, the Tidyverse package, and then you'd have to pull them out of your library in order to actually run it. This is the code I'm talking about here, your data file, name, this percentage, that sign, percentage. This is exactly the code that I ran, only with the data file name of Kate's data, to get R to tolerate missing values. If there are other ways folks like to manage missing data, certainly use those, but R does not like it. It will give you lots of knotted numbers. It will sass you when it can't figure out how to run the commands. And so after you kind of, prep your stuff in order to run the cusp fit, that's just a name. So you're going to have to, you have to call it something. So you can call it cusp fit 1. You can call it whatever you want. This is what you're calling it. The command that you're going to be running is this cusp. This Y is predicted by, this is in Lavon language for anybody who's familiar with that. that is going to be your outcome variable. So again, it's going to be the name from your data file. Oh, and you have to pull out your data file, but folks who know R would already have known that. So again, getting R to read your data file, that's your outcome variable. Your alpha is your asymmetry factor. So whatever the variable name is that you want to run as your asymmetry factor, or something else you could do too that I didn't really explain, but you can add plus, plus, plus. So you can add as many variables there as you want. Again, I would imagine there's no hard and fixed numbers as to what your limits would be variable wise to incorporate as asymmetry bifurcation factors, but it's kind of like regression, right? Like there's a threshold. Eventually you don't want to throw in the entire kitchen sink, right? Because at some point it's going to be less meaningful. So you don't want to have 15 predictor variables in a regression. I would imagine the same kind of applies here. You can add in a bunch, but not the whole kitchen sink. So again, here you can write plus, another variable name plus, another variable name if you want, comma, right? There's your syntax. Your bifurcation factor. So again, for the AFS one, for example, I had that hope plus treatment condition, and it can tolerate binary because that was a binary variable there. So again, that was a yes, no variable. And then your data file, right? And so that will run it. It will save it as that thing. And then when you pull the summary of that, it will give you all of the indices that I described. These are my references. And these are, Ken will explain to you kind of what I did, why I did it, my rhyme behind the, anyway, all of that. So pending your questions, that kind of brings us to the end. Kind of finished a little bit fast. Any thoughts or like what would be your concerns moving forward using Cusp modeling? Is something that you guys might want to use? Nobody, crickets. It's okay. I got good jokes. I have undergraduates I teach. I could tell you guys bad jokes too in the meantime. What do you call a fish that's fancy? Anybody know? Fancy fish. Sophisticated, right? It's pretty good. Thank you. Thank you all for laughing. I got more where that came from. Why did the Scarecrow get an award? He was outstanding in his field, right?
Yes, thank you.
It's amazing. I know. I'm going to stop sharing. I can talk to you guys.
Oh, no, don't, like I can certainly.
Yeah. So any other thoughts, questions, concerns moving forward? It's a lot of complicated stuff.
Find uses for those jokes of the variables.
Say again? I'm sorry. It's kind of breaking up on my end.
Oh, yeah. I wanted to ask about collinearity. Like, say I have multiple variables I want to feed into this model, and they're somewhat related to one another. Like, how does this model handle that sort of thing?
Yeah, I would not want that. And I can't tell you why, but my gut is I would not want collinearity for similar reasons, because it's just going to mess up your results. Like, and I'm not smart enough to explain mathematically why I wouldn't want that, but those are the kinds of things that I would screen out. Again, with Kate's data, I didn't have to worry about those problems. Had they arisen, I would have disentangled that in some capacity.
Okay.
Yeah, thank you. Yeah. Other thoughts, questions?
I have. Sarah, I just wanted to say thank you. That was a really, really masterfully presented because this is really complex. This was all brand new to me, and I feel like I followed the presentation really easily.
Thanks.
So thank you for doing such a nice job breaking it down for us. I think this is kind of in the weeds, but one place I got stuck was just trying to think of examples of bimodal outcomes. Can you share some outcomes that you think are continuous but have two clear states that aren't binary in nature? Because thank you for calling out that it's distinct from binary.
Yeah, there's a lot of interesting applications. So the first one that's coming to mind, it has nothing to do with psych, but and it's also, according to veterinarians, is not it's not accurate, but that's okay. It's helpful to think about, like dog aggression, right? So dogs can kind of experience aggression on this platform, but then there's the biting or not, right? Does the dog bite or not? And so there's this kind of idea with fear plus aggression, there's this dog bite. So that is one application. I'm thinking in terms of PTSD continuous outcomes. Again, I'm way more well versed in PTSD stuff. So I would think in terms of PTSD threshold or not, right? You're going to have continuous variables on your CAPS or your PCL5, and there's clear PTSD or not, right? I'm trying to think. Gosh, the like emotion regulation would be another one, depending on whatever your measure is of emotion regulation.
So it sounds like
Having variable amounts.
So it sounds like a lot of the variables that are on a continuous scale, but have a clinical threshold for like,
That could be
yes,
a way
you
to
are
think about it.
clinically considered depressed versus not, or okay. Thank you. That's super helpful.
Yes, that could be a way to conceptualize it a priori. However, sometimes, again, my advisor may not like this because sometimes I go grounded theory and he doesn't love that. I'm like, sometimes you look at what you got in front of you, right? Like if you're looking at something in front of you and it seems like some sort of something is going on. Again, my advisor would not condone me saying this, but anyway, that could be something worth looking at, right? If you're noticing two different things, I mean, in his stats guy is looking at, he's got time series data for folks who were experiencing episodes of mania. And so he's going to do some analyses with that. And so there are clear episodes between when one is manic and when is not manic. And he's got some variable stuff to look at various things, right? So I guess, yeah, clinical thresholds can be a rule of thumb, but I wouldn't recommend getting super wrapped around the axle with it unless you've got a huge data set and then you might, you know what I mean? Like, I don't know if that's helpful or not, but try my best. Other thoughts, questions, concerns? Yeah.
Sarah, this was fabulous. And I think my video might be breaking up. Can you hear me okay?
I got you. It's a little patchy, but I got you.
I'm going to turn video off and then hopefully my audio will work better. And forgive me if you've already addressed this, but I'm already thinking about this in relation to Kate's Cove study that she's doing with military veterans. And is more time points better throughout follow-up? Because that's more of an EMA study. And I was wondering, because in a lot of applications, more time points is more better, but I don't know if that applies here.
Yeah. So I used this with Kate's data, right? I know you know Kate's data better than anybody, right? So the benchmark that I had in terms of my dissertation stuff, they're like, you need to do a longitudinal study. I'm like, okay, fine. And I was working with what I had, right? Secondary analysis. More is certainly better. It's going to give you a much clearer picture of what that cusp looks like in real time for somebody. So the cusp that I had, right? And I didn't go into the weeds of Kate's data. I'm making some assumptions that folks know Kate's data. So those data points that I had were at baseline, 1 month. What did I have, Amanda?
3 months, 6 months,
12 months. Right. So that gives you what the cusp would look like with snapshots in time over the course of a year. While interesting, if I'm in the trenches with somebody clinically, that's not going to be super informative, right? And so what you guys are developing there with the EMA, I think even for me, like I said, as a clinician, that is far more meaningful to understand what that risk looks like at closer intervals, because I'm not going to meet with these people only at that frequency of time, right? I'm going to be meeting with folks far more often. So that would be interesting to know what those patterns look like. And then, hopefully what I think could happen with some of this stuff is that it's going to inform clinical practice guidelines moving forward, right? Like if we understand what these patterns look like, we can identify indicators of risk for different folks who fall along different pathways. So again, I think there's a lot of utility that can happen with this kind of analysis. You guys are doing an excellent job of developing all that. So anyway, thank you for that. Any other questions, comments, thoughts?
Fantastic.
Bad joke.
And I hope you're going to teach.
Thank you.
I hope you're thinking about it.
So I'm working here in Colorado Springs with the El Paso County Sheriff's Office. And so I've been doing a lot of wellness training with cops, which is fun. They also are not a very good audience because they don't laugh much. So I take a lot of joy in trying to get them to chuckle at my bad jokes and, share some mental health resources and things like that. But it's fun. I like teaching. I like being a guest instructor. That's more fun, right? Because then I don't have to grade. Grading is not my favorite.
You can be our guest anytime. This was amazing.
Oh, thanks. Thank you. That's meaningful. I appreciate that. I see a hand raise, Ian.
Yeah, thank you, Sarah. Can you hear me okay?
Yeah, I got you. I might have to turn you up a little bit on my end, but I got you.
Sorry.
Did I lose everybody?
No, having fine. To do this mobily, so I apologize.
No worries.
This is such an interesting approach, and I was particularly curious about the results with the hope variable, and we're in the midst of. My name's Ian Bennett. I'm the PI of one of our R34s in our center.
Okay. Oh, so hope. So could you elaborate the question a bit more? It's hard for me to grab all of that.
And I was just curious what your thoughts might be. This is not a mathematical question. This is more of a question of monitoring and the use clinically. Of a hope question as part of the EMA, both self-monitoring of patients and to help clinicians keep an eye on how people are doing. I just wondered if you had any comments on that.
Like how clinicians could kind of track hope? That is a good question. I mean, we have measures, right? But that's not always going to land well in session and clinic. I mean, that is a way, but really hope, the meat and potatoes of hope is agency, right? Feeling like you can do something, that you have the ability to do something, and you've got a way to get there, right? So those are really the 2 meters that I would try to track clinically. Do you feel capable of doing the things you need to do to get to where you're going? That's kind of how I would do it. That's theoretically informed from Snyder and colleagues. But in session with folks, I would think that being able to grab something, right, that they can see something, even if it's just making it to the end of the day, how they're going to do that, I think would be a clinically meaningful way to gauge it. I mean, for the purpose of research, we can certainly throw in some psychometrically valid stuff to track it. But that's kind of what I would do. Does that answer your question?
Yeah, I appreciate that. Thanks. It's a this ongoing conversation, and I'll follow up with our folks, our experts on suicide monitoring in the center to think about that.
Yeah, cool, awesome. Yeah, I'm glad to help out. That kind of brings us to the end of our time today. So thank you all for attending. I hope everybody learned a little bit of something and go forth and do cusp models in your everyday life.
Yeah. And we'll have a recording available for this shortly. So
thank you for watching this seminar from the University of Washington Suicide Care Research Center. Please take a moment to complete the anonymous evaluation to share your feedback. If you would like to receive a certificate of completion, be sure to also complete the attestation. Links to both surveys are available in the description of this video. Your input is much appreciated.